Hi students, in this lecture we are going to discuss about the properties of polymer. The very important property is the glass transition temperature. Glass transition temperature is the temperature at which the amorphous solid state is transformed into melted state. Below the glass transition temperature, the polymer is very hot, and above the glass transition temperature it is very soft. The hot brittle state is called as glassy state, and the soft flexible state is called as rubbery state. And this is the examples for polystyrene and polyethyl acrylate. Next, factors influencing glass transition temperature. The value of Tg depends on chain length, the extent of cross-linking, the barriers which hinders the internal rotation of the chain links, and the value of Tg of a given polymer varies with the rate of heating or cooling. Below Tg, the polymer is very hard and brittle like a glass. The Tg of a linear polymer is very sharp because of the free movement of polymeric chains. A cross-linked polymer does not possess any Tg because the polymer chain will not move. So, the polymer with a symmetrical structure are very crystalline in nature, while the polymer with a regular chain are amorphous in nature. Coming to the next property of a polymer, it is a stereospecific polymer. In this, there are three types. It is otherwise called as tacticity of a polymer. It tells us the orientation of monomeric units or functional groups in a polymeric molecule can take place in an orderly or disorderly manner with respect to the main chain is known as tacticity. It does not affect the physical properties of a polymer. So the first type is isotactic polymer. So if functional groups are arranged on the same side of a main chain, it is called as isotactic polymer. So if you take polystyrene, here if you see the benzyl functional groups are attached in the same side to the main chain. So it is called as isotactic. The next one is syntactic. So if functional groups are arranged in an alternating fashion, it is called as syntactic. So if you take the same polystyrene polymer, here if you can able to see the benzyl groups are arranged in an alternate fashion, so it is called a syntactic polymer. And the last type is atactic polymer. So here the functional groups are arranged randomly. So if you take the same polymer polystyrene, see in two cases it is in the downwards, and in the other two cases it faces upwards. So it is called as atactic polymer. So the next is molecular weight of a polymer. Solution, softening temperature, tensile and impact strength, and heat resistance are influenced by molecular mass. Generally, low molecular weight polymers are very soft and gum-like resins. The high molecular weight polymers are tougher and more heat resistant. So therefore, determination of molecular weight of a polymer is of greater importance. The molecular weight of a polymer depends on the type of monomer involved in the polymeric reaction. The final product will contain the macromolecules of different masses. So most of the polymers are polydispersed, that is, the molecules of a polymer do not have identical molecular weight. So it is necessary to take average molecular mass. So there are three types in that. One is number average molecular mass, it is denoted by Mn bar, and the next one is weight average molecular mass, it is denoted as Mw bar, and the third type is viscosity average molecular weight, it is Me bar. So coming to the number average molecular mass, it is the mass obtained by dividing the total mass of the polymer material with the total number of molecules present, and it is mathematically represented as like this. So it is a formula. So Mn bar is equal to total mass of the polymers divided by total number of the polymers. So here where Ni is the number of monomer molecules and Mi is the mass of the simple monomer molecules. The next, coming to the determination of this number average molecular mass, it is determined by measuring its freezing point, depression, elevation in boiling point, and osmotic pressure. Next, coming to the properties, Mn bar is good index of physical properties such as impact and tensile strengths. It is not good index of other properties like flow. Next, weight average molecular mass. So weight average molecular mass is not only depend on the number of particles but also depend on the molecular size. So here is the formula, and in that M1 is the mass of a monomer and capital M1 is the molecular weight of a monomer. So coming to the formula, summation of Ni Mi square divided by summation of Ni and Mi. So this is determined by light scattering techniques and ultracentrifugation techniques. The properties, always weight average molecular mass is greater than number average molecular mass. Next one is Polydispersity Index. So it is the ratio of weight average molecular weight and the number average molecular weight is known as Polydispersity Index. So this denoted by PDI. PDI is equal to MW bar divided by M1 bar. Thank you.